Hi, how's it going? All right, so this is a talk about a waiting for Rx, a play in 4 acts. It used to be 5 acts, but we only have 45 minutes, and I got to move fast. So I am at PolicyBets on Twitter, on GitHub. I work for GitHub. My day job is working on GitHub for Windows and GitHub for Mac, mostly GitHub for Windows. So I write a lot of C# all day. Yeah. In my spare time, I write a lot of Xamarin libraries, as featured. A lot of the libraries that I write are around trying to make it so that you can write cross-platform code, and I write all the platform code so you don't have to think about it anymore. And that's really cool. So I wrote a library called Modern HTTP Client, which lets you use really awesome platform-specific networking libraries, but it hides it behind HTTP clients, so you don't have to think about the fact that you're using NSURL session, but you don't know it. So that's really cool. And a bunch of these libraries use the reactive extensions, which we're going to be talking about today. So how many people have heard of the reactive extensions for .NET? It's a library you can find on NuGet. How many have used it or and have had success with it? A lot less, but cool. So we'll talk about a little bit about what Rx is, and we're going to talk about how it works with async await. So async await, the new exciting Microsoft technology. How do you put them together? How do you compare and contrast these two? We're going to learn about that today. So that's really cool. But before I can go into that, so why Rx? So we've got async await. It's really cool. Why do we even do we need reactive extensions anymore? I don't know. Let's find out. So have any of you ever seen this blog? Parallel Programming with .NET. This is a blog by Stephen Taub. I really like it. It's got a ton of useful information about using the TPL. But the thing that I don't like about it is that so many of these articles are basically like, here's this really reasonable block of code that you could totally write, and here's all the bad things that happen to you when you do it. And that's not great. So why is writing async code so tricky? And so the thing that I'm excited about with reactive extensions is it makes writing async code a lot more dependable, a lot more reliable. I can write something and be pretty sure that it's going to do what I want, and testable. So that's really cool. I can write tests that run the same way every time, and do what I think they're going to do. So, and there's another problem with async await that I think is a little bit more subtle. So you may not believe this statement. Code is communication between people that just happens to also run on a computer. So maybe you're like, nah, I write code for computers. But if you keep that in mind, over a long period in your project will end up way better. Because people will be reading your code, extending your code. You'll hire new people. They'll have to learn about how your code works. And so I want code to be very understandable to other people. That's super important to me. So I like to think of good code like a stage play. So a stage play is a little different than a movie. In movies, you can have all these quick cuts. You can move between places. You can be in Beijing in 1 minute, in New York City in another. In a stage play, you can't do that. People have to run off stage. You have to close a curtain. Right? You've only got 4 or 5 people on stage at a time, right? So when you write screenplays for stage plays, you have to say this really one concise idea, and then move on. And so they have kind of a really solid concept in one place, and then they move to the next scene, because they can't do too many scenes at the same time. So code is like that. I want all of the idea around a feature to be in one really readable place, or even like the idea around a UI interaction. What I don't want is code that is all over the place, right? I have a callback here, then it goes over here, then I have this other callback that jumps over here. Callbacks are kind of like today's go-to, only worse, because they're even harder to understand. They make it really difficult when you add a new feature to your mobile application to figure out all the different places it's changed and how it affects the rest of the program. I want to be really concise. So that's what I don't like about async await, is that I can't be concise. And the reason I can't be concise, because await doesn't help me get away from state, mutable state. It's the enemy of every user interface application. The more mutable state I have, the more difficult it is for me to figure out when a program is correct or not. And when I use async await, it's still imperative code. It's not functional. We're not describing things declaratively. We're just writing the kind of same code we did before, only it kind of secretly adds callback. So it's definitely better than what we had before. But we don't want to spread code over a bunch of different places. We want to have it all in one place for describing a single feature, a single concept. Don't get me wrong, I love async await, but I'm going to tell you why it sucks. Let me continue. Tasks don't help you with events, right? So tasks model one kind of event, which is the asynchronous operation. So we make a network call, we run some CPU-bound process, we calculate the digits of pi in the background and come back once. So what it doesn't help us with are old event callbacks. You can kind of wire them up if you do some work. It doesn't help us with UI events, right? You can't await mouse move easily. You can do it, but it doesn't. You find that even if you can do it, it looks a little weird. So what we really want is we want one language to talk about all these three things. Because really events and callbacks and a task returning from being completed are really all events, right? They're all the same thing. But we can't refer to them in the same language, right? I have to use a func of something for a callback maybe, and then an event, I have to add a delegate. And for tasks, I have to await something. I'm treating all these unified things as separate things, and I can't combine them together really easily. And so when I can't combine them together easily, I can't describe how they're related easily. So I have a UI button that has a click event, and I can't describe how the click event is related to this asynchronous go and do a Google search and then come back. I want to directly tie the click event to the callback result. And you could say, maybe I can do that with one thing, right? I can wire up a click event. They're related. But then if I keep adding more complicated things, if I want to chain these things, then it gets weird. Or describe how they're related with other parts of my code. Nobody creates .NET events. Very rarely does anyone add a new event to their own classes because they find it too cumbersome. It's just too much of a pain. It's not as easy as it should be. So when we use events and tasks together, we unintentionally write spaghetti code. We want to be concise. And the thing that I really like about Rx is that I can be really concise. I can go down, if a PM writes a spec for a UI, how this UI should work, I can take lines of the spec and then make them as blocks of code, even if the actual result is going to a bunch of asynchronous results and coming back and doing all this stuff. So I want to have code where my code is really relatable to the spec. I think that's pretty cool. So in 5 minutes, I will attempt to teach you calculus and also convince you that it's cool. Here we go. So in this talk, I'm going to show a little bit of production code. If you don't understand it, that's not a big deal. But I want to show a lot of people who demonstrate the reactive extensions show these really kind of contrived mathy examples. But I want to show that more interesting examples. This kind of muddies the concepts a little bit, but I think that it's still pretty valuable to show that this works in all kinds of different apps. It works in user interface apps. It works in server apps. It works in all kinds of places. So the core of Rx is this object called iObservable. And so if you've seen some of the Rx talks, iObservable is the dual of IEnumerable, which is a fancy way of saying that that all the cool things I can do with enumerable, I can do with iObservable. And so you can think of iObservable as a better event. So this code doesn't work. I can't take events in .NET and assign them to a variable, right? The only thing you can do with an event, you find out if you like really dig into the CLR that events are super weird. Like you can't assign them, they're not expressions. The only thing you can do is add or remove a delegate. They're a really like specific thing tied into a language construct. But anyway, so that's a bummer. So observables are events that you can just assign to a value. We can assign it to a variable. We can combine them together and do whatever we want. So that's really cool. So this term in functional programming is called first class. Events are first class objects in reactive extensions. So this is a little hard to believe if you haven't heard it before, but events are just lists backwards. So consider that this guy, window key up, right? So when I have LINQ, I have, how many people have used LINQ and like know it pretty well? How many people understand the concept of like deferred execution in LINQ? Like the idea that if I do like enumerable.range 1 to 1,000,000 .select, nothing happens. Nothing happens until I for each, right? So that's really important to understand. So let's go back to key up. So with LINQ, we took simple arrays and turned them into more interesting arrays. Arrays that are more related to what we actually want to figure out what's going on, right? We're taking data and filtering it and mapping it and selecting and aggregating where it until we get a more interesting array. So we look at key up. And somebody types HELLO. Well, that was just like a list, right? It was some stuff in a particular order. Like the contract of IEnumerable is you keep pulling off items until it ends, or there's an exception, like it throws an exception when you go move next. So an event is kind of just the same thing, right? We're getting data back in a certain order, not necessarily sorted order, just any order. And so if we can do that with if events and lists are kind of the same thing, we should be able to do all the cool things that we can do with lists like selects and wheres and filters and aggregates and do the same thing to events. And so that is what Rx is. Reactive extensions are taking all the cool things that you can do in LINQ and then applying them to events. So you can think of observables as a timeline. And so observables in reactive extensions can do three things. They can call onNext, which means that they're providing new items, just like a key. Every time you type, you get a key event. They can complete. They're saying, like, there's no more events. Or they can complete with an error, which is like it's the same as IEnumerable. IEnumerables, you call move next, and it either returns false, it's saying there's no more items, or when you call move next, it throws an exception. This is the same thing. So it's important to know that once you complete an iObservable, you will get no more items. So they're done, finished. That sounds like a onerous limitation, but in fact, it's not so bad because of the way that you can combine observables together. So with this abstraction of like a timeline with onNext and onComplete and onError, we can model all kinds of stuff. Modeling events is really obvious, right? Mouse up, mouse move. Modeling tasks, well, tasks are just an event that only happens one time. Callbacks are an event that only happens one time. So here's how you would model task as an observable. Nothing happens, nothing happens. It responds with a value and immediately completes. So this is a task that is run successfully. It only gives you one value just because task of T has .value. It doesn't have .values. So remember how LINQ is deferred, and nothing happens until you for each, right? So some observables are like that too. So there's one observable called observable.return. And the only job of return is to just immediately give you the value passed in and then complete. So you give it observable.return 42. You subscribe to it. It gives you 42 on next, and then on completes. So, but if that was like an event, that would be useless, right? Because as soon as you called observable.return, it returned 42 incomplete. And then you subscribe to it, and nothing happens. Like you missed the boat. So many observables are called cold observables, which means that when you subscribe to them, nothing happens until you subscribe to them. Subscribe is a method in Rx that is like for each. So we can use this to our advantage. We can make it so that anytime we subscribe, we get a network request. Or we can decide that we don't want that, and the first time we subscribe, we get a network request, and the rest we get the same can value. We have a lot of flexibility about how we can decide to what happens when you subscribe. And so the other kind of event is called a hot observable, which is more like an event that you're used to. Subscribing does nothing, and it's always happening in the background whether you listen to it or not. Everyone gets the same result. Mouse move is a hot observable. Most events are. So how can we combine reactive extensions and task of T? In fact, it's really easy to combine these two. You don't have to pick either async await or reactive extensions. You can use them together really easily, and that's really cool because you can do you can write the async await parts of your code and write Rx parts for other parts, and that's really cool. And here's the coolest part. This is the part that you should take away from this talk if you don't learn anything else. You can await iObservable. You can actually await anything. There's a bunch of demos. Frank Kruger is here at Xamarin Evolve, and he wrote demos where you can await a button. The only thing you do is you create a method called getAwaiter on whatever class you want. And the trick is that method can be extension method. So you can bolt it on to any class you want. You can await a Boolean. You have to decide what that means, but you can totally do it. And so you can await any iObservable as long as you using system.reactive.link. That's the trick. Is that Visual Studio is not usually clever enough to figure out that it's an extension method, and it'll be like, I don't know. I think ReSharper will find this for you, but Visual Studio out of the box will confuse you. So what does it mean to await an observable? An observable gives you more than one item. How can you await it? Tasks only give you one item. So these two pieces of code are semantically the same, kind of, mostly. And so the idea is that when you await an observable, you get the last item. And then so this is like this. The line above is like the async await version, and the line below is if you didn't have async await, you write this instead, and you call subscribe. Awaiting is also like subscribing. Awaiting will cause whatever it happens when you do call subscribe to be evaluated, because it has to return a real value. Generally, the rule with link and Rx is if it returns iObservable or iEnumerable, then nothing happens until you subscribe or your for each. If it returns a value, then you know that it has to evaluate it, that it causes the expression to be evaluated. So the catch. You must guarantee that the iObservable terminates. And that seems easy, or obvious rather, but it's really easy to fall into traps. Say you have mouse up observable. If you await it, you'll wait forever because it never finishes, right? Goes on forever. So your code, you'll write await, and you'll be like, oh man, why doesn't my console write line? So there are a few operators in Rx that make things awaitable. Take is a really good one, because you can say like for any observable, you can say like take one, and then you get the first one. You can say like skip 5, take 1. I want the 5th one. Aggregate is a really useful method in Rx. It's actually a really useful method in Link too, but a lot of people don't understand what it means. Anytime you want to take n items and reduce it to one item, that's aggregate. It's super useful. A lot of people, it's the most underused, in my opinion, operator. The clever thing is, though, that one thing that you reduce it to could also be a list. And in fact, you can implement all the link operators using aggregate. These are called reducers. Rich Hickey wrote a whole talk about them. So UI events never terminate, but we call take one. Now it totally happens. Cool, we were clicked. And then since this is a hot event, I can just keep calling await over and over again, because it's just going to keep going. We're just going to keep taking an item. So the moral of the story is that tasks and observables are super interchangeable. You can always take a task, can convert it to observable. You can take an observable and convert it to a task. It's really easy to go between these two worlds. And really, once you get good at it, you'll find that certain parts of your code are more convenient to write in Rx, and certain parts are more convenient to write in async await. And you can totally choose whichever one you want. What's even cooler is that you can use Rx operators to bolt on cool features onto your async await code. So I have this method called readAllTextAsync, and as it implies, it's the async version of readAllText, which doesn't exist, but pretend it did. So readAllTextAsync, there's some pieces that I have to explain. So in this method, we want to give it a file, and if that file doesn't exist or it blows up for some reason, we have this default string we want to return, whatever. It didn't work. So readAllTextAsync is, you could think of it as hot, right? As soon as you call it, something's going to happen. But what we're doing below is we're going to change that up a little bit. And so we're going to make it so that we're going to make this lazy. So the idea is that we're not going to do any file reading until somebody subscribes. And the method that we use to do that is called defer. So defer makes it so that when nothing happens, this method is not called until somebody subscribes. Every time somebody subscribes, we're going to call that Lambda file readAllTextAsync. So we're taking this async method and then bolting on some cool features to it. We're bolting on this retry. So it means that instead of trying to read the file once, we're going to try to read the file once. If it fails, we're going to do it again. If it fails, we'll do it again, blah, blah, blah. And if it really doesn't work, we're going to use this operator called catch. And catch is going to say, oh, it really didn't work. Use this other observable instead. And then other observables return, which is what I described earlier. It's just going to return a canned value. So we took our async await method and bolted on some cool features onto it. Another really cool method that is really useful is called timeout. So we can make it so that whenever we make a network request, we can say, if it doesn't come back in a certain amount of time, I don't care, fail it. And then when that fails, we could say .catch and decide what else to do with it. We could return a different value. So the reason that we need that defer up there is because otherwise our retry would just get the same value 3 times. So we need to make it so that every time retry subscribes to the source, it gets a new value, instead of getting the same value 3 times, the same failing value 3 times. I'm moving really fast, but hopefully that makes sense. Maybe not. Questions, comments, concerns? No? Cool. Everyone understands everything. They're all experts. Perfect. So sometimes writing it the pure Rx way and forgetting about async await completely is cleaner, is easier to understand. And sometimes it's not. Sometimes, in particular, if you have to, an error condition that you want to return early from, before that you handle the main kind of if the inputs are bogus and return fail, if this is true, then return this. It's often easier to write that with async await. But sometimes it's easier to write an async await method using Rx. So this is the same method without any waits. And the thing I really like about Rx and that I really like about LINQ is that we can see the path from input to output. Sometimes that's not so easy to read when you write async await code, because you can have lots of conditionals, you can have all kinds of ins and outs. When you write Rx, you write a pipeline. You start with inputs and you end with outputs. And that's really cool. And in here, we're doing the same thing. We're calling this toTask. So we're taking this observable and turning it into a task. And that task, this method, we could await in some other part of our code. And it would work just the same as any other async await method. So that's cool. We knew Rx, but the people calling this method didn't have to know Rx. So there are many async-friendly Rx operators. So these are Rx operators that have overloads that understand async await, which is really useful. One of the most useful ones is select many. So have you ever used, like, created a link query and then had the result like, oh, I want to call an async method in my link query. Oh, crap, I can't do that. Like, it doesn't work. Select many is like a select that understands async await, which is super useful. So one of the things you can do in Rx is take arrays and convert them to observables, where as soon as you subscribe, it runs down the entire list as fast as possible. So if I have like 1, 2, 3, 4, 5, .to observable, I subscribe to that, and immediately goes 1, 2, 3, 4, 5 on completed. So I can take that, I can say, like, have this canned array, to observable, .select many, and run that through an asynchronous method. And so all those go out concurrently and then come back. And then I can decide what to do with it. One of the things that's super useful to do is what I'll show in a few minutes. So one of the disadvantages of async await is that it often introduces ordering constraints that are unnecessary. So I want to fetch 3 pages of tweets. I don't know why I want 3 pages, but humor me. So in this loop, this is really easy to read, but it's not that fast, because even though we're doing this asynchronously, we're not blocking, we're still fetching these pages in order. And we don't really care about the order. We just want all 3 pages. So like I just mentioned, we're taking 0 to 3, .to observable. We're going to select many into awaiting for get tweets. Now, you actually don't need that async and await because it returns tasks, but it makes it more readable. Anyway. And then, so we're going to get a 3 on next in arbitrary order, because network requests can be rearranged. They can come back in whatever order we want. But we don't really care about the order. We're going to take that, and we're going to reduce it into a list. And so this is actually a built-in method called toList. So that was really cool. Now we're making all 3 page requests at once and then putting them together. And if any one of those 3 page requests fails, the entire thing fails with on error, which is generally what we want in this case. We could say that maybe we just want to ignore failures. We say, like, oh, if one of these pages fails, then we'll keep rolling. And we could do that too. By default, it means the whole thing will collapse. This is MapReduce, or in C# lingo, select aggregate. So that's pretty cool. So we implemented our little version of MapReduce in a few lines of Rx. So here's a more production fancy version. So this is 10 pages, because 3 wouldn't work. So there's a few problems with the previous version. So we made as many requests as we possibly could at a time. So that means if I had 100 pages, then I make 100 web requests. That's not good. We generally would like to retry fetching a page before we give up. And so instead, instead of select many, we're going to do select.merge. And so the way that I wrote this, I really like to use indentation to describe how the flow in the pipeline is. So we can say toObservable.select.merge.aggregate. And so we're selecting it. We're taking a list of parameters and selecting it into a list of requests, of pending requests. So these are all in-flight requests. And they're lazy requests because I use defer. So that means nothing happens. So I've selected it into 10 descriptions of how to make a web request, almost. So it's a deferred get tweets, and we're going to retry 3 times if any of those fail. This is the part where your minds kind of like melt into liquid silicon. It's fine. That's OK. And so we're going to say we want at most 4 requests in flight at a time. And so as requests come back, we're going to subscribe to new ones. And because it's lazy, until the subscription happens, we're not going to make the web request. So that's really cool. We've used this idea of deferred execution to our advantage. And then we're going to do the same thing as before. We're going to aggregate into a list. So the cool thing about that is that get tweets didn't have to know anything about retries. It didn't have to know anything about merge. It didn't have to know anything about concurrency. I was able to bolt that on to a method that was really dumb or really focused on the goal that it was trying to do. It didn't have to think about all these other concerns. And you find that like you'll try to bolt these concerns on ad hoc in a very not systemic way. Like you'll find a bug and you'll be like, oh yeah, I need a retry. Go, you find a bug. Oh, I need a timeout. Like Rx lets me create my own operators or use the ones that are built in to add functionality to a place that normally is kind of hard, would normally result in me fiddling with a bunch of stuff and doing it in a very ad hoc way. So that's really cool. So when to use async await and when to use Rx? Always use Rx for UI events. If you find you're writing this code, writing infinite loops and awaiting them, that's weird. That's not, no. We don't want to do that. So that's much better. This describes my intent way better. We're saying events where something is OK, subscribe and unhighlight. I think there was an example from Phil Hack's blog. I don't remember. So I have this really cool NuGet library called reactive-UI/events. And so reactive UI events has nothing to do with reactive UI in the sense that it's not a dependency. But what it does is I wrote a program to reflect through every single UI toolkit, read all the events, and then create a bolt-on extension method to give you observables. Let me show you an example. And this works for iOS, Android, WPF, everything, I think. Xamarin Forms, it's a very important one here. So to every UI object, and you can write this in the Vue code, it adds this method called events. And then events return to a class that has every single event, every single .NET event, but as an observable. So when I can say events, resize, now I've got an iObservable that returns me an event handler or event args of whatever, resize event args, something. And so what I'm saying here is when either the window resizes or moves, wait 5 seconds and then save the window placement. So that's really cool. That would have taken me a lot of like weird jumpy code to try to figure out to do. I can combine events together. That's really cool. I can combine events with all kinds of different things. So the goal that we're trying to do is describe an entire process in one place. And so this is a production example. It's a little bit complicated, but. So at GitHub, we use this service called Speakeasy, which is a service I use this term service loosely. It's a crappy Rails app that we wrote that helps you do enterprise updates for iOS. And so if you do enterprise updates for iOS, you have to check for updates yourself. You have to invent the mechanism to figure out when an update exists. And so this is the entire code in the iOS app that I write internally to check for an update, prompt it for the user, and then run their update. So it uses async await and Rx together. So at the first part, we use await to check for an update. We're going to make a web request. And then if something bad happens, we're just going to forget about it. We're going to determine whether, if update info should prompt for update. We're going to figure out if we have the newest version, basically. And so here's the cool part, is that React UI events maps all of the Cocoa delegate classes and creates like a dummy version where all the events are observables too. So I'm going to create an Rx version of UI alert view delegate. And so I'm going to create a UI alert view. UI alert view is like the dialog, just like pop up and hit OK or cancel. Right? We're going to show the dialog, and then we're going to wait for them to click a button. So we await an observable representing the button. So that's pretty cool. And then of course, Apple is super jank. They like return their button values as like non-enumerable, but like just like a number. If it's 1, that's okay, right? And if it works, then we're going to attempt the update. So it's really cool. I described that entire flow that involved asynchronous network requests, that involved user interface dialogues in one place. And I really like that. Describing an entire process in one place is kind of the goal. That's what we want to do. Rx is really good at describing pipelines of data. That's one thing that if you have to choose between Rx and async await, then Rx is really good for. When you write declarative functional code, it's easier to test. It's really easy to, it's harder to test async await code because we have to deal with all this state, mutable state. We want to get rid of mutable state. But await methods get the job done. So when I write code that combines the two, I often use Rx for the high-level methods, like the kind of things that coordinate what's going on, and async await for the really low-level ones where I'm like, calling out to services and then figuring out what to do. And so I have an example of this. This is from, I was writing my own build server because I love suffering, apparently. At one point, I shelved this, thankfully. But it was really cool because like build servers are kind of a pipeline. Like you start with a request to make a build, and then it goes through this series of steps, and then it finally ends with like a finished build result that you broadcast out. And so I described this pipeline of like this, you call it like workflow of like walking through in one hideous Rx query. But that was cool, kind of. I liked it. But the important part is this middle part where we jumped out of the Rx world where it was convenient and started using async await to await the actual like running of some build, like running MS build and like getting a result out and saving the fact that it worked. So we can always jump out of Rx and think in an async await world. One of the cool things about Rx that I didn't mention until now is that Rx lets you substitute in. Rx runs everything that is a deferred action, anything that is real concurrency, like we're going to run it on a different thread, through this object called iScheduler. And so that iScheduler can be replaced. And so the nice thing about Rx is that you can turn methods that in production run things on other threads, and in a test runner, run things like synchronously in a single thread that don't do anything interesting, and the tests happen the same way every time, which is really cool. So we took our async await code and replaced all the things that would normally run on other threads, and replaced the scheduler with a dummy scheduler that did nothing. And so now our tests are very dependable because they have no concurrency. They do the same thing every time. One other thing you can do that really helps you to combine Rx and async await is to use extension methods to provide task-friendly APIs. Running out of time, so I'm going to try to move fast. I wrote this library called Punch Clock. Punch Clock is really cool. It lets you, it means you can issue a bunch of requests, and then it will kind of like order them and prioritize them. So it will only allow like 5 at a time, and maybe you think that some of them are more important than others. And so you can say like, I would like this one to run skip the end of the queue and he gets to go first and the other ones don't. But you only run n at a time. So the core of punch clock is this single method called enqueueObservable operation. And it looks pretty scary. What? So it's really nice to be able to use Rx for the implementation, but then expose this interface that uses task so people can use. People who don't have to be familiar with Rx to use your library. So I do this a lot. I always expose a task-friendly version. And so onto that method, we bolt a bunch of methods that return task. And so these are just extension methods. They just use the built-in method and then call to task. And then it kind of converts cancellation tokens to the Rx version, which is outside of the talk, but anyway. And so now when people use it, they just call this, which is way easier to understand. Hooray. OK, my slides are on SpeakerDeck. Check out my profile for punch clock. Don't read peasant. Just pretend it didn't exist. Follow me on Twitter. Yeah, yada, 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 yada. Thanks so much. We have 3 minutes and 14 seconds for questions. Three minutes and 5 seconds for questions. I will also allow rants, raves. Please don't throw tomatoes. Yes?
The one method that you put up there was a series, a long pipeline, right? Mm-hmm. Debugging, how do you do that?
Well, ideally, as they say, if the types match, then your program works, right? So the question was, how do you debug this stuff? So one of the methods that you can use for really lazy debugging is called do, which just lets you execute a method. And so that method can be console write line, like printf style printing. You can use the standard debugging tricks like breakpoints and stuff like that. Rx makes it really easy to sub in dummy objects. So anytime you have something that returns an async result, you can also, that was the part of the talk I cut. You can sub in a dummy object, right? You can just return, throw, wait 10 seconds, and then return. You can simulate all kinds of these different complicated scenarios around and so it's really, what you really do is you set up tests, unit tests. So you try to avoid debugging. You just unit test everything. Because you make it so easy to unit test, then why wouldn't you? So. Yep. Just talk loud and I'll repeat the question.
I was just wondering in the context of mobile applications, especially with iOS, where you have events and you need to unsubscribe from these events to avoid memory issues. How does that factor into Rx?
Yeah, so the subscribe method returns an iDisposable. The question was, how do you unsubscribe? So it returns an iDisposable. If you dispose that, you're unsubscribing. However, you only need to unsubscribe if it terminates early. As soon as an observable terminates for any reason, all of the subscribers are let go. And so there's different ways to terminate subscriptions. One thing that's really cool is if you create an observable representing when you leave the page or some other sort of lifecycle event in Android or iOS, like on stop or on pause, create an observable for that, and now you can say .take until that observable. So you can automatically cancel anything you put out by saying just oh yeah, if this signals, then just drop what you're doing, forget about the whole thing. And then the act of unsubscribing, if you build it correctly, frees all the resources associated with it. So if you're making a network request, unsubscribing should cancel that network request. And if you do it right, then that works really well. So it's really easy to set up these cancel conditions. You're I only want to have this. If any of these things happen, and you can combine all kinds of different events to say if any of these events happen, then forget about this, cancel the whole thing. That was a good question, because that's really important to do. Like, canceling network requests when you move a page is pretty huge. You should definitely do that. Anything else? Cool. Well, I will be around. Just grab me and ask questions about other things. I'm giving another talk tomorrow about this project called Starter Mobile, which kind of takes a bunch of the libraries that I write and puts them together. And it's mostly about reactive UI, which is this UI toolkit around the reactive extensions. So we're going to do a lot of reactive extensions in that talk too. So come out for that. That's tomorrow at a time that is non-zero. I don't remember. I'll figure it out. So yeah, and that talk will all be demos. There's no slides. We're going to walk through an app. We're going to like build like a kind of a really simple like connect to a web and like do some requests and do some stuff, display it on the screen kind of app. So yeah, cool. Thank you so much.